Okay, so we're back now, and this would be lecture number 4, and this is where we left off on the last lecture that I just did. We were talking about the standard deviations and how the standard deviations, we needed to look at if whatever the standard deviation value was, in this case it's a 4, then we need to look, if we say we're within 1 standard deviation of the mean, we always need to remember that that means if the value is 4, that's 4 points above the mean and 4 points below the mean. A lot of times people will forget and they'll only go above the mean and forget that we also need to look at the scores that fall within 1 standard deviation. In this case, it equals 4 points below the mean, as well as 4 points above the mean. Now, in looking at this, what we're talking about with this type would be, we're looking at the curve in terms of, like, it's not a bell-shaped curve because we've got more on the right side of the mean than we do on the left side. So what we need to look at here is from the standpoint of how is this particular distribution of numbers skewed. And what we can say here is, if you look and you see the mean is here, the medium and the mode is there, all right? If the mean is less than the medium and the mode, then that means that the curve, the hump portion of it, is going to be on that end, and then we slide off this way, and so that means it's skewed to the left. We're not looking at the hump, the way the hump goes. That's not how we skew it, or that's not how we determine if it's skewed right or left. We're looking at the part where, like, the ski slope goes down and you slide off. So we're saying this is skewed to the left, and when it's skewed to the left, it means it's a negative skew, right? That means that, and it depends upon who you look at and what they use as a reference point to determine if something is skewed to the right or the left. Here they're saying that the mean and the medium are left to the mode. You're going to have others that will say if the mean is to the left of the median. So we want to think in terms of just whatever way it's going to be the easiest for you to remember. Now, if 85.5 becomes our median, which is what we had on the second block over here, it would fall here in this distribution. And then our mode is 88, that's going to fall there. So what we see is our mean is to the left of the medium and the mode. And so that makes us have a left skewed or negatively skewed shaped curve. If we had the other way, in other words, if everything was on this end, if we're talking that, say, this was the median, or this was the mean, and the medium and the mode were over here, then we could say that this would come down, we're skiing out this way, and that's going to say we're skewed to the right. The way the arrow points, you're skewed to the right, and that's supposedly a positively skewed bell-shaped curve. So let's look at some more examples of this, because what they may do, and what I will probably do, is I'll ask you a question, and then I'll give you a little picture like this, and then ask which of the following pertain to this representation. Is it skewed to the left? Is it skewed to the right? Is it a positively skewed curve or a negatively skewed curve? And so when we talk about the distribution of scores, if they're asymmetrical, we don't have that bell-shaped curve, the curve is distorted or what we call skewed. If it is a positive skew, the little ski slope thing, you ski out to the right. If it's a negative skew, you're going to ski out to the left. So a normal distribution, also called a symmetrical or a bell-shaped distribution, your mean, your medium, and the mode are all going to be the same. If we've got this here where we've got the mean is greater than the medium and the mode, Okay, we say this is a right-shaped skew because what happens is we're not looking at the hump, we're looking at the way we ski out. So you ski out here to the right, that's going to be a right direction skew, so that's a positive skew. If our mean is less than the medium and the mode, so if our mean is here and we're less than the medium and the mode, we're going to come down, ski out this way to the left, and so then we call that a negative skew. You can't look at the way that the hump leans. You look at the long, low side. Think of it as the way that you're going to ski out down the mountain, the way you come, after you come off the hills and you're coming down, you're skiing down to the ski lodge for a drink. Okay, and here, this is kind of a little bit different because what they're talking about here is, I always look at it from a standpoint of the mean, where the mean is, but this basically says the same thing, but they're looking at the mode as their reference point. So they're saying that if the mean and the medium are to the right of the mode, then you're going to have a right skew, which means you're going out this way, and that's going to be a positively skewed. Same thing you're looking at here. If your mean is here to the right, then you're going to go with a right skewed. Okay, if your mean is to the left, you're going to go with a left skewed here. So it just depends upon, they may ask you about the mode, they may ask you about the mean and the medium. So you just kind of want to think of it in a relationship of which way they're asking and how you're going to do this. So skewed, negatively skewed, if your mean and your medium are to the left of the mode, it's going to be a left, you're going to ski out to the left. If the mean and the medium are to the right of the mode, you're going to ski out to the right. So your mean is 81, your medium was 85, and your mode is 88. You've got something like this where they've already plotted it out for you. So this is what your curve is going to look like here. So if we look at this and we say, okay, the mean is here. We're going to say our median is 85, so it's going to be in this area. And our mode is going to be 88, so it's over here. So again, it just depends upon which way it's going to be easiest for you and what they ask. If we're talking the mode and the medium are to the left of the mode, we're going to ski out to the left. That's going to be a negative. If we had this was the mode and these were the mean and the medium, then this curve would be going this way and we'd be skiing out to the right, and that's going to end up being a positively skewed. I think probably what they'll ask is going to be more along the lines of, they'll give you a picture like the small pictures above, and they'll ask you, is this a right or a left skewed distribution of scores? Or is this a positive or a negative distribution? And the thing to remember is, if you ski out to the left, it's negative. If you ski out to the right, it's going to be positive. I can't see them having to have you chart where everything is and then deciding which way to go. Okay, correlational coefficients now. There are 4 basic types of correlational coefficients, and usually they'll indicate a correlational coefficient by -R, okay? You have 4 types. You have a chi-square, Spearman-Brown, point serial, or Pearson's R. I think most of the time you see a Pearson's R utilized, but you want to be familiar with all of these because they may say, Spearman-Brown, which of the following would indicate the greatest relationship using a Spearman-Brown calculation. And you'll know basically what that is. We're talking a correlational coefficient. Which one you use depends upon what kind of data you have, whether you have nominal, ordinal, ratio, or interval data. I'm not going to get into so in depth into it, and the board's not going to get that in depth to it, to where you would have to say which one goes with nominal, which one goes with ordinal, ratio, or interval. Okay. Now, The thing to remember with correlational coefficient is it expresses in mathematical terms the degree and the direction of a relationship among variables. So when we talk about degree, how closely are the variables correlated, or how closely are they related to one another? If, if we're talking about one variable moves one step, the other variable moves one step. If one variable moves one step, the other one moves two steps. So you're talking about how closely they correlate, and then you're talking about the direction, either a positive or negative direction. And this doesn't mean positive is good and negative is bad. An example would be a correlation between income and preventive health care. You can look at this and say, or you see from research, that if you have, as your income increases, your utilization of preventative health care increases also. So you increase 10,000 in your salary, your doctor visits per year go up by 2. You increase another 10,000, so you've got 20,000. Your doctor visits go up, and now it's 4. And then same thing, 30,000, you go up 6. 40,000, you go up 8. That's a positive relationship. Now a negative one, again, is not bad because it's negative, but it means, say, fluoride usage. As the fluoride level goes up, then your decay level goes down. So each part per million fluoride that you go up, the decay level goes down a certain percentage. And so that is, you're talking about a relationship between the utilization of fluoride and the incidence of decay. There is a relationship between those two variables, but it's a negative relationship in that as one goes up, the other goes down. Whereas if we're talking about a positive relationship, your income goes up, your doctor visits go up. So they're kind of going in the same direction. Now, your range for correlational coefficients go from a -1 to a +1. 0 means there's no relationship. A -1 is a perfect negative or inverse relationship. A +1 is a perfect positive. Very seldom do you have a perfect negative or a perfect positive relationship. The closer you get to 1, whether it's -1 or +1, that just means the stronger the relationship you have. And so it doesn't matter if, you're thinking a positive going closer to +1 is going to be stronger than going closer to -1. That just tells you the direction that you're going. The closer you get to that 1, whether it's negative or positive, that means you've got a closer relationship, okay, between the variables that you're looking at. So let's look at some examples. Which of the following correlational coefficients indicate the strongest relationships? If you've got a +95 and a 0.05 relationship, you have to ask yourself, okay, which one gets me closer to a 1, whether it's a -1 or a +1? And what happens is 0.95, that gets me closer to 1. That indicates a very strong relationship, where 0.05 indicates a very weak relationship. -0.62 and a +0.14. Again, you have to look at this. You can't look at it based on like a 0 point. You have to look to see which one is closer to 1, whether it's a negative or a +1. And so if we look at this here, a -0.62 is closer to -1 than a 0.14 is to a +1. So this indicates that there's a midpoint. There is a relationship or correlation between two variables here. It's not as strong as that 95, but it is definitely stronger than the 14, and it's stronger than the 0.05. So this means that there's probably a midpoint correlation, and it's a negative correlation, meaning that one variable goes up, the other one goes down type of thing. How about -0.90 and +0.90? Okay, these a negative 0.9 and a positive 0.9, they are just as strong. So there's no difference between one of them. It just tells you the direction you're going in. The negative 9 is going in a negative direction. The positive 9 is the variables are going in a positive direction. So with the negative, when the variables move, one moves up, the other one moves down. Or one moves to the left, the other one moves to the right. But they're moving. There's a correlation between the way that they move or the distance that they move. Whereas with a positive, if one moves up, the other moves up. Or if one moves down, the other moves down. If one moves to the left, the other moves to the left. Okay, so this just tells you how strong the relationship is between the variables, and that relationship, what direction does that relationship go? Now, you also have to remember that just because there's a strong correlation between the variables, that does not mean that one necessarily causes the other, all right? It indicates that there's evidence that there's some relationship there. They don't know if it's actually a causal relationship or not, but this is a good point where they get these results and they know, okay, we need to do more research here. We know there's a relationship. What's causing the relationship? What is this relationship? So an example would be caries and fluorosis. They're highly correlated. When we talk about a correlational coefficient for caries and fluorosis, you come up with maybe a negative 0.9. Now, that 0.9 is really close to a perfect negative 1. So you say that there is a strong relationship, and that relationship is a negative relationship, meaning that caries incidence goes down as the severity of fluorosis goes up. Now, we know with the severity of fluorosis, we know eventually you can get to the point where the fluorosis is so severe that you actually, it increases, okay, your risk for decay. But when they were first studying this back in the 40s and they're looking at this, they didn't realize that it was fluoride that was causing a reduction in decay. The first studies were looking at fluorosed teeth and the incidence of tooth decay. They didn't know what caused fluorosed teeth, but they knew there was a relationship between fluorosed teeth and tooth decay. And so they were looking at that, and they came up with the two variables were ID'd as a relationship, and a strong relationship there. So that was the first cause and effect relationship between caries and fluoride. Was the correlation that they found between caries and fluorosis. So they realized that reduction in caries, increase in fluorosis, and then that led on to more research, which a good research study does. If a research study should open up questions, several other questions for people to go in and start looking at other relationships. With this, they said, okay, what causes fluorosis then? We need to look at that to see what is the etiological factor in fluorosis. They figure out that's fluoride, so then they can go back and say, okay, increase in fluoride, what happens to the incidence of decay? So this is where we get caries doesn't cause fluorosis. Fluorosis doesn't cause caries. And it required more research to determine what the real causality of this particular phenomenon was. The thing you're going to need to remember about correlational coefficients is that it's going to fall between a negative 1 and a positive 1. If they asked you a question and they've got any kind of answer that doesn't fall within these two, negative 1 and positive 1, if they've got something that says the correlational coefficient was 1.6, that's not a valid research study. That's not a valid answer. They may ask you which of the following indicate the strongest relationship between two variables, and they have things like 0.05, negative 0.62, and one of the answers or two of the answers may be 1.6. or 2.3. You know if it is greater than negative 1, greater than positive 1, right away you can eliminate those two answers. We have to remember that correlational coefficients will always fall within that range of -1 to +1. Now, a little bit more about inferential statistics. This is where we come in with, remember we've talked about t-test and the analysis of variance, or the ANOVA, back when we were talking about when you're trying to conduct certain types of studies and you're looking at 2 variables or more than 2 variables. Okay, the most commonly used inferential statistical techniques are the t-test, and you use that when you're comparing 2 variables, just 2 things, before and after. In one group, their pre-test, their post-test, or you could have 2 groups where you have a before, a pre-test, and a post-test. That in the first group, you look at the pre-test and compare it to the post-test. In the second group, you look at the pre-test and you compare it to the post-test. You look at the pre-test of both groups. You look at the post-test of both groups. We're looking at just 2 things with each statistical manipulation that we do. And so we would be using a t-test, a 2-tailed t-test, or t-test for short. When we start to look at more than those 2 things, then we have to use a different statistical test, and that comes in with the analysis of variance. With the analysis of variance, if we have group 1, and group 1, we have the baseline data, the pre-test. We come out 3 months later and we have another one. We come out 3 months after that and we have another one. Now what we're doing is we are comparing more than just 2 things. You also will take group A, group B, and group C. And if you've got group A, and say we've got a pre-test and a post-test, we've got group B, a pre-test, post-test, and group C, a pre-test, post-test. If I'm looking at group A's pre-test, post-test, I can use a t-test. I look at group B, pre-test, post-test, I can use a t-test. I group C, pre-test, post-test, I can use a t-test. But when I look at the pre-test for group A, group B, and group C, now I'm looking at more than just 2 things, right? I'm looking at more than just 2 scores here. I can no longer use a t-test. I have to go with the analysis of variance. So think in terms of your DMFT scores for high school students that were examined, and you've got 6. If we're looking at DMFT scores of high school students that are examined, okay, that's your sample, that's 6. That's going to be descriptive statistics. But if you start to look and you say, okay, I'm going to take the DMFT score I got for my sample, and I want to compare that or apply that, infer that to all high school students, then I have to start using inferential statistics. So just remember, the thing you need to remember about inferential statistics is when you're inferring the results of your sample to the larger population, that's when you use inferential statistics. Descriptive statistics, you are looking at your sample, and then you're comparing your sample to other samples. And once you get that, then you can go in and you can say by statistically manipulating it, and we're not going to get into what you do and how you do. Just remember these things that I'm going over, and if you see them on the national board, you see them on a dental public health test, you answer it based on what we've covered here. All right. Okay, that ends it. We finished with the content for the remainder of the dental public health course a lot quicker than I anticipated. It's probably because there's no questions, there's no breaks. You know, we're cutting this up into smaller sections that are just, the content is there. I am going to have another session. This one is going to be shorter than the hour, but I'm going to bring up another section in a little bit, maybe tomorrow, where I'm going to actually go over a couple of test questions, and we'll work our way through those test questions. And I think then that will help you also kind of understand which direction you're going to have to come from to answer these public health questions. If you have any questions regarding any of the stuff that we've covered so far, please either FaceTime me or email me, and I'll try to get back and answer them as best as I can. You guys be careful out there. You stay safe. Make sure that you are sheltering in place and staying away from everybody else. Talk to you later.